Very good evening to all the participants. It's a present time. We are hearing to share our knowledge with our resource person. Welcome all. I welcome our management, our secretary of Rajapalayam Rajus College, and our president of Rajapalayam Rajus College, and governing council member of Rajapalayam Rajus College, and also our principal, Dr. R. Jagannath, the man behind our success. I welcome all, and the faculty members of Rajapalayam Rajus College, and the students, and the participants, and our eminent resource person, Mr. Prabhakaran sir. Welcome all, sir. Welcome, sir. Dear participants, it's the time to intro our resource person. Mr. Prabhakaran is a passionate astrophotographer, amateur, astronomer, and science communicator. He has been taking images of celestial objects ever since he started watching it through his first telescope. He worked as an astronomy educator in India for 3 years, and now he is currently working in the United Arab Emirates as an education coordinator at Mleiha Archaeological Center. Mr. Prabhakaran and Mr. Nirmal Raja jointly running a YouTube channel called Scientific Tamilan to popularize science in Tamil for the past 2 years. His work has been published in ISRO, NASA, in many other international forums. Welcome, sir.
Thank you for the introduction.
Okay, sir. Sir, you can go ahead, sir.
Yeah. So good evening to everyone. I'm Prabhakaran, and I would like to thank Rajus College for giving me this wonderful opportunity to showcase my work and my knowledge to everyone. And also I would like to thank Principal Sir and the management for this opportunity. So I hope I'm loud and clear.
Yes, sir, audible.
Right. So in this presentation, I'm going to share my knowledge, and I'm going to take you on a journey through our universe, right from the Big Bang till now. And also I'm going to showcase my work in the sense, the pictures that I've captured. And then also I'm going to explain about these celestial phenomena and then celestial objects. So there will be some pictures and videos. Most of the pictures which I'll be showcasing, in fact, captured by me in this past 5 to 6 years. So I've been doing observational astronomy and astrophotography since 2015, and my passion, hobby, and profession, everything is astronomy. Back in India, I was working as an astronomy educator, where I was teaching astronomy and space science to school students mostly, and also to college and universities as well. And here, after moving to UAE, so I'm mainly focusing on astronomy and also other subjects, along with my colleague and friend, Mr. Nirmal Raja, who did a session a few days back on fossils and evolution, I believe. So apart from my profession, my hobby is observational astronomy. I use telescopes to watch the universe. Whenever I get time, whenever the sky is clear, I just take my telescope and go to a dark site to see the objects. And also, parallelly, I do astrophotography as well. First, I started observational astronomy because of the passion and the interest. And after going through all the process, and after understanding how big our universe is and how fascinating this subject is, so I wanted to share my knowledge, and I wanted to inspire a general public and students and children as well. So that's when I decided to take images of these objects and then showcasing it to general public in various platforms, like on social media, by doing public outreach program. So I was able to attract some people towards astronomy. So then I started to do, like, as a full-time, apart from my regular day-to-day job, was also doing these things parallelly. So whenever I get time, I used to go to schools, orphanages, and I used to do observation of planets and moon and celestial objects. So far it's been great, and I'm looking forward to present this presentation in a more interactive and fun-filled way. Uh, I think I can start the presentation now. If everything is okay from your end, we can start.
Yes, sir. Okay, sir. You can start, sir.
Right. So I also have a small telescope. If you can notice in the background, can you see the telescope? Can you see the telescope? Oh, all right. So, universe through my telescope. This is the topic which I've chosen, and I'm going to show the universe and objects in the universe, not just the universe, objects in the universe through my telescope in the form of images. So, the subject is astronomy. Astronomy is a fascinating subject. It is one of the oldest natural science that we ever started, and we've been doing astronomy ever since we evolved as humans, like hundreds and thousands of years ago. When we started looking at the night sky, now we had a lot of questions, and we were very curious to know about these celestial objects. Now, of course, we know the answers. Like we know the answer about the stars, planets, and galaxies, how universe was formed, and how stars were formed. So we know the answers now. Back then, if you think as a as a person from a stone age, you would be wondering what these objects are. So they had a lot of questions to find out, and whenever they see the night sky, they started to imagine various patterns in the night sky, various patterns of objects in the night sky. So if you look at the night sky, you would see lots and lots of stars, and occasionally you will see some bright stars and some faint stars as well. So bright stars are more noticeable because it's quite obvious in the night sky, and you always tend to make a connection between the stars that you see. These are called patterns. So they started to create patterns in the night sky, which is a mere imagination, and then they started to see the heavens in the form of patterns that they were familiar with, such as birds and animals and humans, which we now call it as constellations. So there are 88 constellations. Out of 88, there are 12 famous constellations, which are called zodiac constellations. So that's how it started, but it has more information to it. There are a lot of history involved in it. So I'm going to cover those things. So astronomy is a subject where you study about celestial objects such as stars, planets, moons, not just our moon, also moons of other planets as well, which are natural satellites, and then galaxies, galaxy clusters, and universe in whole. So having said that, there is a big confusion. In fact, there is a huge misconception between two things. One is astronomy and astrology. So I want to make a clear distinction between astronomy and astrology now. And many people, in fact, in India, many people, they mistake astronomy as astrology. And in fact, most of the people, they only know about astrology. So it's a sad thing to know that, because astrology has reached more people than astronomy, because many people believe in future and they want to know the future. So astrology is a pseudoscience. Astronomy is a science. So you have to understand what is science and what is pseudoscience. Astrology tells that it can predict a person's future by calculating the position of celestial objects in the sky at the time of that person's birth. But according to science, it is not possible to do so. And it's been proved by doing various experiments and collecting various data. But still, astrology fails in all aspects. So astrology is a pseudoscience. It is not a science, but still many astrologers, they they take this particular thing as a science, but which is not. So astronomy is the one that you want to understand, that you want to learn, because astronomy is very important. Without astronomy, you cannot see anything in this universe. Whatever the things that you do, right from the time that you wake up from your bed till the time you go to your bed, everything has astronomy in it. Astronomy is inculcated in our daily lives without knowing. In each and everything that you do, astronomy has a part. Right from this, this webinar, so it is being broadcasted because of the internet, and the internet is because of the satellite which is orbiting on Earth, which is a product of astronomy. So I'm going to cover those things in the later slides. So for now, let me clear: astronomy is science, and astrology is pseudoscience. So there are many subfields in astronomy. There are hundreds of subfields, but I'm going to just cover major subfields. First one is astrophysics. In astrophysics, we study about the properties of these celestial objects, the stars, galaxies, and the physical properties of these things. And then planetary science, we study about the signs of planetary objects such as planets and the things in our solar system, and then about the exoplanets. In astrobiology, we study about the evolution and the origin of life forms in our planet and also in other planets. So cosmology is a study about everything, the entire universe. And then solar physics, study about our sun and its properties. And astrometry, it's study about the position and the movement of celestial objects in the sky. So these are the major subfields in astronomy. So now let's see the history of astronomy. So like I said, we started astronomy right from the Stone Age, but we do not have any evidence that they started right from the Stone Age. But based on other data which we have gathered from the early, like in the first and even before BCE, so all these evidence concludes that it must have been one of the oldest natural science that we have ever started. So I just want to show a video. So here you see, this is Milky Way. This is the galaxy we are living in, and you are seeing rising and setting of Milky Way. So they saw things rise and set. For example, stars, set of patterns, constellations, they rise and set. And they saw moon changes in its phase from crescent to first quarter, and then gibbous and full moon, again back to crescent and new moon. And then they saw sun rising and setting. So they saw periodicity. So once you have periodicity, then what you can do is you can use these things to keep time. So time was the main thing. The society that we are living in is a civilized society, which happened to be because of the time usage of the time, and also because of various other things which I will be covering later. So because of this periodicity, and also because of the patterns in the night sky, they use the entire night sky as in the form of map. So they subdivided the sky in the form of constellations, and then they use constellations and set of stars to do many things. So here I have a picture of the night sky, the northern night sky captured from my place. Here you can see I've made an outline of these imaginary patterns. So these are called constellations. So these are imaginary patterns. So what happens is when you see the night sky, you always try to connect the dots to create a meaningful pattern that you are familiar with. For example, nowadays we have lots and lots of objects. Whenever you see stars, our brain always try to connect the stars to create some patterns. Like if you see 4 stars, you will immediately try to connect these stars to create a square or rectangular shape. So shapes are the first thing which comes in our mind. But if you imagine from a person from a Stone Age, they were able to see only living things such as birds and animals and humans. So they created art forms of these things. So here you can see there is a constellation called Ursa Major, which looks like a bear, which is upside down. So this is the mouth of the bear, and then the body, and then the tail, and then the legs. So this is just an imagination, but they had to develop this because they used stars to find out different seasons, and they used stars to find directions for navigation, and then they used stars to predict many other things. So, for example, if you see a set of stars rising in the evening, that indicates a particular season. For example, summer. And then if you see a different set of stars setting in different direction, then it indicates winter. So they use stars to find out different seasons because agriculture was mainly dependent on these things. So if you know the night sky, then you can plan when to plant the seeds and when to harvest it. And also, if you know the stars in the night sky, then you can find your way out if you're traveling, anywhere in the world. You can find your way out just with the help of stars, and you can find all the four directions. So it was a major key factor for them, not just these things, but also many other aspects. So based on these things, we're going to see recorded history of astronomy in the form of artifacts, petroglyphs, and monuments. So there are four important days in the year, which are called equinoxes and then solstices. There are two equinoxes. One is some vernal and autumnal equinoxes, and then summer and winter solstice. So these indicates beginning of each season. And most of the festivals in all our cultures has these dates as which has a majority of the festivals which coincides with these dates, including in our Tamil culture and also in many other cultures, which has these dates as was one of the important dates in the entire year. So whenever a sun goes around, whenever our Earth goes around our sun, it tends to move from one point to the other point. And also because of our axial tilt, our Earth is not rotating straight. Its axis is tilted 23.5 degrees, and because of that, at some point of time we get more illumination from the sun on particular hemisphere, and then in other time we'll get less illumination from the sun on particular hemisphere. For example, in summers, northern hemisphere is more tilted towards the sun than the southern hemisphere, so we get summer. So it's the same for it's the opposite during winter. So we get winter, and then the southern hemisphere people get summer. And then at 2 points of time, our sun appears to be exactly rising in the east and setting in the west. This is called equinox, which means equal day and night. So we get 12 hours night and 12 hours of day. So these are the four important dates. And to know these things, they built many monuments, and then they made a lot of observations in the form of petroglyphs, and then even disc like this. So this one is a Nebra disc found in Germany, which dates back to 1600 BC. So here you can see sun, moon, and then some stars, a star cluster, most probably Pleiades star cluster, the Kritika star cluster. So maybe they must have used this to find out different seasons, or must have used to note the night sky. And then Babylonians, back in 164 BC, they recorded the comet, one of the famous comet called Halley, which comes every 76 years. They recorded the visibility of this comet when it entered the solar system at that time. And you can see that observation on this tablet. And then another thing, Antikythera Mechanism, which is the first analog computer made by Greece, found in Antikythera Island, so which dates back to 100 BCE. So they used this analog computer made up of wood, which has a lot of gears, to predict the eclipses, and then to predict other celestial events. And then this is a famous Stonehenge, which is in England, a set of rocks aligned vertically. And then you can see on the right side, you can see from an aerial view, you can see the position of these stones in such a way when sun rises in the summer solstice, the sunlight passes through the stones which are placed at the front. It passes through these stones, and then it hits a stone which is called Hillstone. That marks the beginning of summer. And then it's the opposite during winter. So during winter, setting sun passes through the stones, and then it hits the central stone. So this is also to predict and to know different seasons, and also to find out these important dates. And then New Grange, Ireland, 3000 BCE. So this is also another mechanism where sunlight passes through the top passage over there, and then it illuminates the inner columns. And that this happens only during summer solstice. That also marks the beginning of that particular season. And then in New Mexico, which was built during between 10th and 13th century, it's called Sun Dagger. So set of stones placed vertically, and in different time period, such as equinoxes and solstice, sunlight passes through it, and then there are spirals, placed at the back of the stone, where the sunlight passes through like a slit, and then it illuminates in different position based on the different month of the year. So during summer solstice, the sunlight passes exactly right at the center of the spiral, and then during vernal or autumnal equinox, it passes slightly to the right of the spiral, and then during winter solstice, it passes on both the sides. So this indicates when winter solstice or northern summer solstice is going to happen, or winter or autumnal equinox is going to happen. So the next thing is Governor's Palace in Uxmal, Mexico, which was built in 900 CE. So this entire building was a little bit tilted 19 degree, and also it has a lot of depictions of Venus, like more than 600 pictures of depictions of Venus inside the building, which indicates that this building was built to notify the southernmost rising of Venus. Every 8 years, Venus southernmost rising happens, and then to mark that, they must have built this because of the fact that they found a lot of Venus depictions, and also because of its particular tilt of the building. And we've been observing celestial events, and sometimes we see exploding stars. And when a star which is very closer to Earth explodes, it outshines the entire sky. Sometimes it'll be brighter than the moon as well. So once a star exploded, 1054 AD, and many people all around the world, they witnessed it, including Indians, Chinese, and Arabians as well. So Chinese astronomers, they witnessed this event, and they made a petroglyph, and you can see how bright this event was. They compared it with a petroglyph of their palm extended towards the arm length to show how much in size it was, and how much you can cover with your single arm extended towards the arm length. You can cover something like around 4 or 5 moons in the sky. So the event was pretty big, and it was visible for many weeks as well. In fact, they were able to see it even in the daytime. So these are the things which we have found, and there could be many things which are yet to be discovered as well. So I'm just going to quickly show you timeline of the astronomy. So the first thing is in the ancient times, Babylonians, Greeks, and Romans were developing astronomy, particularly Greece. Greeks, they were into astronomy, and they developed many things. In fact, the Earth's inner solar system, and in fact, the circumference of Earth was also discovered by Greeks, by Eratosthenes. And then in the medieval period, Islamic astronomers, Chinese and Indian astronomers were developing astronomy based on Babylonians and Greeks and Romans' work. And then later, scientific revolution took place. So back then we were believing in Earth's inner solar system, but after the scientific revolution, heliocentric model was proposed, and then it was approved by. It was in fact approved by data, like by visual observation with telescopes. And the invention of telescope was a major thing for the new era in astronomy. So astronomy is everywhere. Like I said, we can see astronomy everywhere in the form of spin-offs. There are a lot of spin-off technology that you can see in our daily lives. I can give you like a lot of examples. So in fact, the computers that we are using, it was a product of spin-off. Most of these things have been created for astronomy, for astronauts to use it in space, but we are using it in our daily lives. So these are called spin-offs. And also, apart from spin-offs, astronomy applies to majority of the things that we do in our daily life. So I'm just going to share a few examples. The pacemaker that we use, that was invented for astronomy. And then there are many things in healthcare systems like monitors, food safety, wireless headset that we use, communication satellites, water filtration, air purifier, mobile phones, GPS, solar panels, MRI scanner, and X-ray luggage bags that officials use in airports, and then memory foam, tin foods, packed foods, dry foods. The CMOS sensor, the sensor that we use in our mobile phones, was invented for this. Smoke detectors, infrared ear thermometer, shock absorber, and foam. There are hundreds of examples that I can tell that astronomy is in our daily life. So with or without knowing. So now I'm gonna talk about Big Bang. So we're gonna see how the universe came into existence. Roughly 13.8 billion years ago, universe expanded from a small size, as small as the size of an atom, to its present size, right? And it was not an explosion; it was rather an expansion. So it was pretty hot and dense, and over the course of time, like after a few 100,000 years ago, then atoms came into existence. They were able to form, like protons and neutrons. And after a few million years, stars were able to form from a group of gas and dust. We call it nebulae. So it's like colorful gas in the sky, in the space, where all these gases, they come together because of gravitational disturbance, and then they become stars. So leftover of the stars becomes planets, the leftover of the planets becomes moon, and then asteroids and comets, and many of the small solar system bodies. So it's the same process happening in our solar system, and it's the same process which is happening in all other solar systems which we are observing. In fact, throughout the entire universe is the same process. So just going to show you a video. So we are zooming into a famous constellation, Orion, and a famous nebula called Orion Nebula. This picture was captured by Hubble Space Telescope, and by going inside, you can see. So when a gravitational disturbance occurs in this cloud, so what happens is all these atoms, they come together and they coalesce, and then because of lots and lots of atoms coming together, it creates friction. Because of that, it heats up. When it reaches certain temperature, then it becomes a star, not exact star that we see, but a protostar. And then it starts a process called nuclear fusion. So it combines, hydrogen atoms to helium atoms, and then helium atoms to carbon, and carbon to nitrogen, so on and so forth, until iron. So this is a process which is happening within our sun, and also in all other stars that you see in the night sky. So this nuclear fusion creates a force, it creates a pressure which opposes the internal gravity. So every star has its own mass. So because of its own gravity, it compresses in on itself. And that is being pushed by the pressure exerted at the center because of the nuclear fusion. So when both are, stabilizes, that's called equilibrium, equilibrium. So when that equilibrium stage attains, then it becomes a normal star, a stable star, and then that star will live for many hundred to billions of years depending on its mass. Our sun is 4.5 billion years old, and it will live for another 5 billion years. There are many stars, there are many massive stars which lives for a few 100 million years, and they die. So depending on the mass of the stars, some stars, they die in a form of gigantic explosion which can outshine the entire galaxy which is in, called supernova. And if the star is so massive, then it becomes a black hole after the explosion as well. Stars like our sun cannot go as a supernova, but in fact, but rather it will become a white dwarf star after leaving all its outer layers. So after a few billion years, roughly a billion years later, galaxies were formed, including our Milky Way galaxy. And then if you see the galaxy, each galaxy has black holes. And these are supermassive black holes. There are two things. One is stellar black hole, which are formed after the death of a star. And the supermassive black holes are right at the center of the galaxies. All the galaxies that you see in the night sky has these supermassive black holes at the center, which are very big and massive than stellar black holes. For example, our black hole, which is at the center of a Milky Way galaxy, is called Sagittarius A, and that is pretty big, and it is 4 million times massive than our sun's mass. So you can imagine how big and how massive it is comparing to our sun. And then another black hole. This is a familiar black hole. In fact, this is a real image, the first ever image of a black hole captured by Event Horizon Telescope. I believe it was captured last year. And this one belongs to a galaxy called M87, which is in Virgo constellation in the night sky. And this is one of the massive galaxies out there. And it is like many 100 million times massive than our Milky Way galaxy. And I think the black hole's mass is something around 6 billion times, if I'm not wrong. And then there is a huge question, and we are looking forward for the answer by doing experiments like on Mars, whether if any other life form exists other than our Earth in our universe or in our solar system or in our neighborhood. So we've been trying to find the answer. So far, we haven't found any other life form, even in the form of fossilized form. We haven't found anything on any other planets yet, including Mars. But we have found existence of water on Mars, and also in other solar system objects orbiting other planets like Jupiter and Saturn. We have found a lake made up of liquid lake made up of methane in one of the moons of Saturn called Titan, and also we have found 4 moons orbiting Jupiter like Europa, Callisto, Io, and Ganymede. Among these 4, we found few moons might have liquid ocean underneath its surface, so we could find some life form. But it's a matter of time that we need to send a spacecraft, and it needs to drill the surface, needs to find out whether it has or not. So it's just a matter of time. But so far, we haven't found anything. And whatever the exoplanets that we have been discovering, so far we have discovered around 4,000 exoplanets. Some Earth-like planets as well, where the planet is not too close to the star or not too far from the star to remain in a liquid form, the water to remain in liquid form like our Earth. But so far we haven't found any other planets which has life form in it. So we do not have that much technology to find out if it has life form or not. We can find what's the composition of the planets, of the extraterrestrial exoplanets, planets orbiting other stars, but we don't have enough technology to find out if it has a life form or not. So hopefully in future we may be able to find it. And then solar system, it has 8 planets. You may ask the question, how about Pluto? Pluto has been declassified to a dwarf planet, because in order to be a planet, it needs to follow certain rules. There are 3 major things. In order to be a planet, the planet should be spherical in shape, and it should orbit the sun, and it should clear its orbital path. There should not be any other massive object in its orbital path. So Pluto, it satisfies the first 2 things. It's a spherical object and it orbits the sun, but it has a major moon. It has a moon. It has 5 moons. Among 5 moons, one of the moons is called Charon, which is like slightly smaller than Pluto. So they both orbit mutually, and also Pluto enters the orbital path of Neptune. Because of these things, they had to declassify to a dwarf planet, because there are many other such dwarf planets in our solar system beyond Pluto. But there are talks that hopefully in future they are going to promote again Pluto to planet category, because of the results which came out with New Horizon mission. So it took amazing pictures of the entire system, Pluto and its moons, and it seems like it's geologically active and it has a lot of features. So it's definitely promising to see Pluto back to its planets category. So these are the pictures captured by me over the years, starting from Sun, and then the Mercury. You can see some craters, and Venus. Mercury is the first planet, and although it is closest, but it's not the hottest. Venus is the hottest planet because of its atmosphere. Like it's primarily made of carbon dioxide, and because of that, it has runaway greenhouse effect. So it is more hotter than Mercury. And then we have Earth, and then we have a moon orbiting around our Earth, and then we have Mars. Mars looks red and it has polar ice caps. It's similar to our Earth, and it has two moons. And then we have Jupiter, which is the biggest planet in the solar system. Between Mars and Jupiter, there is a belt called asteroid belt, where you have millions of small space rocks we call asteroids. And then beyond asteroid belt, we have Jupiter. Jupiter has 79 moons so far, and also many other moons will be discovering in future. And among 79, 4 of the moons are bigger. These are called Galilean moons, discovered by Galileo Galilei. And then one of the moons is called Ganymede, which is bigger than planet Mercury. And you can see some features on this planet, like some giant storms. In fact, there is a storm called Great Red Spot, which is 2 times the size of Earth, a hurricane 2 times the size of Earth, and it's around 600 kilometers. Its speed is 600 kilometers per hour, and it's been spinning there for the past 400 years, ever since we pointed the telescope towards the object. We've been seeing that particular great red spot, which is not in the vicinity in this picture. And then next we have Saturn. Saturn has 63 moons, and also recently they found many more moons as well. So right now Saturn has most number of moons in the solar system, and also it has beautiful majestic rings, which you can see. There are plenty of rings, like 6 to 7 rings are there, and you can see there is a division between the rings. This is called Cassini division. And then the rings are pretty large, and in space it covers like 400 kilometers in diameter, 400,000 kilometers in diameter. To translate, it's about the distance from our Earth to the moon. And then although it is pretty wide in space, but it's very, very thin. It's the ring's thickness is mere 10 to 15 meters. So comparing to its width, its thickness is very, very, very thin because of various factors. And then we have Uranus and Neptune. So I'm going to show an animation of how our solar system is formed. So like any other planets in our universe, so when our sun was forming, all these left over, like all the heavy elements and then the gases around it, started to coalesce. And the heavy elements, because of the gravity, it stayed within like close to the sun, and then the gases were pushed away. So that's how gaseous planets were able to form away from the sun, and they were able to attain bigger and bigger in size. Whereas the heavy elements closer to the sun, they were able to coalesce, and then after over many billions of years, we have these 4 planets. All these 4 planets are rocky terrestrial planets. So right from Mercury till Mars, and the rest of them are ice giants and gas giants. So Jupiter and Saturn are called gas giants, and then Uranus and Neptune are called ice giants. So there are other things in our solar system like asteroids and comets. So comets are similar like asteroids, but they remain far away from the sun because of the lack of sunlight. It's covered by a lot of gases in the form of frozen, in a frozen form, like carbon dioxide, water, ammonia, and then methane, ethane, and so on and so forth. So here I'm just showing few things. First one is asteroid belt. Like I was saying, Asteroid belt is between Mars and Jupiter. The second one is Kuiper belt. Beyond the orbit of Pluto, there is a huge region where plenty of comets and asteroids are residing, including some dwarf planets as well. And then beyond this Kuiper belt, there is a big cloud called Oort cloud, named after the person who hypothesized, called John Oort. And then this place has millions and billions of comets. So in some point of time, because of gravitational disturbance, some of the comets will be pulled into the solar system, some will be pulled out. Whenever the comets are pulled in, it comes and it impacts the inner solar system objects. Most of these objects are sucked in by the giant planets like Jupiter and Saturn, but some impacts on Earth. So here there is an animation. It's not an animation. Is a real data captured a few months back of an asteroid, 1998 OR2. You must have heard this asteroid in the news. It came very close to the Earth, and at that time I was able to capture the movement of it. So you can see it's moving from top to bottom. So there are many such asteroids which are orbiting our Earth, which are orbiting closer to our Earth as well. And back in the days, like you must have heard about the asteroid which killed dinosaurs. So we've been getting plenty of these impacts right from the beginning of Earth, right from the formation of the Earth. And even every 100 years, we get small objects entering our atmosphere and then impacting on the surface. So we have to look out for these asteroids. So that's why we have many missions looking for near-Earth objects to protect everyone on Earth. And then sometimes, whenever our Earth enters that debris field of the comet or asteroid, then all those small space rocks enters our atmosphere, and it creates a shower called meteor shower. If you see one sudden flash of brightness in the sky of a small rock, we call it as shooting star. But these are not stars; these are space rocks. In fact, I have a space rock with me. I'll show you after the presentation. And then on specific time period, you can see hundreds of shooting stars in an hour. So these are called meteor showers, and there are two prominent meteor showers: Perseids and Geminids. Perseids happens in the August, and Geminids happens in the month of December. So this one is Geminids, was captured last year, but unfortunately last year it happened on a full moon day. So although it happened on a full moon day, but still I was able to see some 100 meteors over the night. But when you have moonless night, like when the moon's phase is crescent or new moon, so you can see like at least some 200 to 300 meteors per night. So these are the meteor showers. Like I said, August Perseids and December Geminis. These two are the prominent meteor showers. And then our Milky Way Galaxy, from a dark side away from the city, you can see the Milky Way with naked eye. You don't need telescope nor binoculars. You just need a proper dark adaptation. You need to adapt your eyes to the darkness without looking at any bright light. And you can see Milky Way and its central band, its central glow, and its dark dust obstructed by the dust and gas in our vicinity. So you can see all those things from a dark place. Back then, before the industrial revolution, people were able to see our Milky Way Galaxy from all the places on Earth. But after this revolution, we are not able to see anything from the city. You need to go away from the city, like 100 or 200 kilometers. You have to drive away from the city to a dark place, to a rural place, to see our Milky Way Galaxy. So this is a picture of our Milky Way Galaxy captured from one of the darkest places here in UAE. We can see the arc of the Milky Way Galaxy. So in summers, you can see the bright band, which is the central part of the galaxy, where the black hole is, and the other side is the winter galaxy, which is visible during the winter. That's the corner of the galaxy. So since we are living in Milky Way Galaxy, so if you see from our planet, you would see one portion of the Milky Way in one particular season, and then the other in other season. As our Earth moves around the sun, so you'll see one portion of the sky and then the other portion later. And then there are a lot of galaxy groups and clusters. So galaxies are formed together in the group of groups. In our Milky Way, there are 54 galaxies, which is called as local group. And these groups, they are in the form of clusters. Like many multiple groups, they come together and they become a cluster. And these clusters, there are many hundreds of clusters, they come together and they become superclusters. And these superclusters are in the form of bigger superclusters, and they comprises the entire universe. So universe is bigger than you could ever imagine, and we are just a small little planet in one corner of the universe. So I just want to show a few pictures of galaxy clusters which were captured a few months back. So this one is a picture of a galaxy cluster called Virgo, and you can see plenty of galaxies, all these faint smudges of galaxies. And the giant elliptical galaxy, the one which I was showing with the first ever image of the black hole, it's this on the top left corner. So that's M87 galaxy. And then this one is a Hercules supercluster. All the faint dots that you are seeing in this image, except the bright stars here, are individual galaxies. There are at least some 500 galaxies in this image, and each galaxy has billions of stars. Our Milky Way has 400 billion stars. So on an average, if you take a galaxy, it should have at least 100 billion stars. And there are trillions of galaxies in our universe, in our entire universe, observable universe. And if you do the math, the number of stars in our universe would be more than the number of sand grains on entire Earth. You go to all the beach, you just count the number of sand grains, it will not match the number of stars in our universe. And if you take a mere percentage, like let's say just 1% of the number of stars in our universe, it would have billions of planets. And if you take just a few percentage of that particular billions of planets, you will end up with millions of Earth-like planets. And there could be some planets with some life form as well. So if there is no other life form in our universe, then it would be an awful waste of space having this big universe. But it's just a matter of time. We may not be able to find out if there are any life forms or not. There may be no other life forms as well, but we do not know yet. So it's just a matter of research and time and technology for us to find out. So this is the observable universe. It could be much bigger than what we have estimated now. I mean, the entire universe, not the observable universe. The entire universe could be many times bigger than the observable universe. The reason why I'm saying that it is observable universe is that's the limit. That's the horizon that we can see in space. Beyond that, we can never see, because time will not allow for the objects, for its light to reach us. So the observable universe, its diameter is around 93 billion light years. You may ask a question, how come our universe is only 13.8 billion years old, but the observable universe is 93 billion light years in diameter? The universe is not static, it's expanding. In fact, its expansion is accelerating. So right from the beginning of the universe, 13.8 billion years ago, right from that moment, our universe has been expanding. So if you take that expansion into account, so our universe has expanded far beyond than the 13.8 billion years. So whatever the things were back then, now it is around 93 billion light years in diameter. So beyond that, whatever the objects which are beyond that limit cannot reach us. So we may never able to see anything beyond this limit. And also there is another thing called even horizon in space. It's not the black hole. It's not related to the even horizon in black hole, but it is something else. So although it is 93 billion years, but whatever the object which are now, if the light from these objects reaches us, then it will be only within like 18 billion light years from our Earth. If the object is beyond 18 billion light years, if it sends a signal, or let's say if the light leaves from that particular object, in future it may not reach us. But if it leaves, if the light from the object leaves now, it can reach us. But in future, it may not, because of the expansion and many other factors. So I know it's a bit confusing, but to keep it simple, our observable universe is 93 billion light years in diameter. And then the actual universe could be many folds bigger than the observable universe. So if you want to start visual observation, you have to understand the night sky. Every day, go out and look at the heaven, see the stars, look at the movement of moon. Moon moves pretty quickly because it is closer, and you can see the phase changes because of the illumination from the sun. And also you can see planets also move. The planets are closer to sun, it moves faster. So you can observe these things, and you can understand the periodicity, and you can understand the night sky. There are many softwares and mobile apps which are out there. For instance, this one is an app. It's a software called Stellarium for desktop. It's a free software. So here you can see, you can learn the night sky with this, and you can also go out and you can learn it in real time. So once you know these things, then you can get a binocular, and then you can start looking these objects like star clusters, few bright nebulae, and then moon, different phases of the moon, and then some craters on the moon. You can start watching it through a binocular. Later you can purchase a telescope if you want to see it much closer. But to begin with this, you don't need a binocular or a telescope. Just need your naked eyes and a dark place to see all these things. So to identify a difference between a star and a planet, if you see an object which twinkles, that means it's a star. And if you see an object bright and doesn't twinkle, then it's a planet. Stars twinkles because it is pretty far away from from our Earth, so it appears its light source appears like a pinpoint source. And because of our Earth's atmosphere, our atmosphere is like it's like a water. If you put a stone, it ripples and it acts like a wave. So if you try to look at that stone inside the water, because of the ripples, it won't be very steady, right? In a similar way, our atmosphere makes the light, go zigzag, like it goes up and down. Because of that fact, it twinkles. Whereas planets are pretty close, and its light appears like a disk. It doesn't appear like a pinpoint source like stars, but planets appears like a big disk shape. So that dispersion, that zigzag pattern, it cancels out on both the sides, so it doesn't twinkle much. But it does twinkle, but it is negligible when you observe it with the naked eye. So that's how we can differentiate. And then there are different types of telescope. The one that I have in the background is a refractor telescope. There are three different major types. So if you want to begin, reflector telescopes are cheaper, and refractor telescopes are slightly costlier than a cheap reflector telescope. I don't want to get deep into the working principle of telescopes and all, because I don't have enough time. So I'm just gonna show you my website, and then I'm just gonna share few of the images which I've captured. So this is my website. So I have full disk images of the moon and some close-up images of the lunar features like craters and mountains, and then Sun, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and then moons of other planets, asteroids, comets. So this is full disk image of the moon. It's captured in different time periods, so it shows different phases. And then some close-up images of surface of moon. So you can see the craters and mountains. So these craters are big craters are something around 100 kilometers in diameter. So through a big telescope, you can see these things visually, and it's breathtaking. And these are some images of the sun captured in different wavelength. These were captured with hydrogen alpha telescope. You can see the prominences. These are some features on the sun. You cannot observe it with a normal telescope, with a filter telescope. First of all, you should not look at the sun with or without telescope. You need filters to protect your eyes. Sun is so powerful, it can burn your retina in fraction of a second. So you should not look at the sun without any filters. We have to watch only with filters. So you can see some features like sunspots as well. Occasionally, you'll see some dark features on the sun because of magnetic field activity. Sometimes it has these dark features called sunspots, dark spots on the sun. And then Mercury, it is very tough to observe because of its close proximity to the sun. So it appears always in the evening and morning along with the sun. So it's very hard to observe. But in some period of time, you can see it for about, you have a window of about an hour before the sunrise or after the sunset, depending on the time period. And Venus is second planet. This image was published in one of the social media handle of NASA, and also it has been published in many other astronomy magazines and many other forums as well. So this is a picture captured over a period of 2 years, right from the left to right. You can see its phase changes, and also its apparent size also changes as our Earth revolves around our sun. Venus also revolves around it. Because of that factor, you get to see different phases, because Venus is inferior planet. It's between Earth and then the sun. So you always get to see different phases. So this was captured from 2018 to 2020 to see all these changes. And then Mars, you can see the polar ice caps and then some features. Sometimes you can also see some volcanoes as well. One of the biggest volcanoes in the solar system is called Olympus Mons. I think I have captured that, but I'm not able to find where it is. But you get an idea. So that's how we can see Mars through a telescope. And Jupiter, you can see all these cloud details, like different layers called zones and belts. And sometimes you can see the great red spot. I'll try to, yeah, here it is. You can see the great red spot, like oval in shape. Some images were captured in different wavelengths to enhance different features on the planet. And Saturn, you can see the division and also some features on the planet as well. There's a polar hexagon on its northern pole. And then Uranus and Neptune. These are very hard to observe because it appears very small because of its distance from the sun. And then natural satellites. This one is Ganymede, the biggest moon of Jupiter, and Titan, biggest moon of Saturn, second biggest moon in the solar system. And then asteroids and comets. This one is a famous comet which came very close to Earth last month and this month, called Neowise. I was able to get some details, tails and different tails like ion and dust tail, and then the nucleus. And then artificial satellites like International Space Station. So you can observe these things through a telescope. You can see the solar panels. Sometimes even, with big telescope, if there are any astronauts who are doing spacewalk, if you have big telescope, if you can capture it, you can get the details of the astronaut as well. Few of my fellow astrophotographers have captured astronauts doing spacewalk, captured through an amateur space telescope as well. And then deep sky objects. So these are things which are very far from our solar system, very big in space. Star clusters, nebulae, galaxies, Milky Way, and some close-up of Milky Way, night scams, like just the sky, night sky and constellations, stars and star trails. These are different types of photography. So you have different types of clusters, like two different types. One is open cluster, which has newly born stars, like young stars, and the gravity is not very strong. So the stars in the cluster is it's loosely arranged. It's not very tight. Whereas The globular clusters, they are very tight, looks like a blob, and they have fairly old stars, and they appear like oval, like a blob through a telescope. And then nebulae, a group of gas and dust where stars are being born. So there are many nebulae in our galaxy. This one is elephant's trunk because it looks like an elephant's trunk. So most of these nebulae are named after how it appears. This one is called Horsehead and the Flame Nebula because of its appearance like a horse head. And then this one is called Pelican Nebula. It looks like a pelican bird. It's very tough to imagine that. And this one is it's called Crescent Nebula because of its shape. And then it's called Lobster Nebula. It's called Cat's Paw Nebula because it looks like a cat's paw. And then Ring Nebula, this one is a dead star. When a star dies, like I said, it leaves all its outer layers, and then over the time it becomes a white dwarf or any other different types, and it is being eliminated by the central light and also central star and also the nearby stars. So you get to see the dead star in different colors because of its different elements in it. And then this is called Rosetta Nebula, looks like a rose. It's called Swan, which looks like a swan. It's upside down now. And this is called Eagle Nebula. It's a famous nebula, and at the center there is a famous picture of Hubble. It's called Pillars of Creation. It's a star factory. And this entire nebula looks like like an eagle. If you see it in sideways, this is the center of the eagle. These are the wings. But also, if you look at it straight, you will see it looks like a face of a lady, eyes closed. So this is the eye and nose, and then the chin. And you can see it looks like a lady, pretty much. But these are just patterns, imaginary patterns. And then Trifid Lagoon. And this is the famous Orion Nebula in Orion constellation. The Crab. This is also another dead star. Do you remember the star which was exploded around 1054 AD, 1054 AD, and was witnessed by Indians, Chinese, and Arabians? So this is that object. So this object, what you see now, is after that explosion. All the outer layers of the stars. You can see it even now through a telescope, but it's very faint now. And this is the center of Orion Nebula. These are the stars which are at the heart of the nebula. So these are the bright stars which illuminates the entire nebula around it. And Hubble has captured this in absolute detailed image, which you can see on YouTube or in NASA website, which will take you through the cloud in 3-dimensional, where you can see all the stellar nurseries. Like right now, hundreds of stars are being born, including the planets around it. You can see it if you go to NASA's YouTube or website. And then galaxies, there are, like I said, trillions of galaxies, and there are many galaxies which are closer to our Milky Way, and it appears bigger. So this one also, it appears in different shape because of its vicinity, because of its angle. Generally, galaxies are flat, like spiral in shape. There are some galaxies which are in different shape as well, irregular in shape and elliptical in shape. So this one is an lenticular galaxy because of its vicinity from Earth. It's edge-on, so slightly edge-on. So it appears like a UFO. And this one is like phase-on, so you can see the view is phase-on, so you can see the entire disk and then the clouds. You can see different colors as well. It's called Messier 83, Southern Pinwheel Galaxy. That's Centaurus A. This is a pretty big galaxy. And this is the closest and the biggest galaxy that you can see. In fact, this is the farthest naked eye object. If you go out to a dark space, you can see this galaxy with the naked eye. This is called the Great Andromeda Galaxy, which is the closest galaxy to Earth. And then some group of galaxies, Sunflower Galaxy. And then here you can see I have highlighted a star. That's a supernova. A star exploded a few months back, and I was able to capture it. And then some group of galaxies. And here, two galaxies are colliding. So both the galaxies are emerging into one. So this is called whirlpool because it looks like whirlpool. So every now and then, this galaxies, they collide and they merge and they become one single galaxy. So likewise, our galaxy also, merged into many other small galaxies as well. The Milky Way, like I said, from a dark sky, you can see the Milky Way pretty clearly. A few of the images captured from a dark sky, not a complete dark sky, but fairly, we measure the darkness of the site from bottle 0 to 9. 9 is the most light polluted place, 0 is the least polluted place. So these images were captured from bottle 3 to 4. And then nightscapes, constellations, stars. Sometimes you can see double stars. Most of the stars are double and triple. They are in groups. Our sun is a fairly lonely star. And then there are some celestial events as well. Like every now and then you have interaction of celestial objects, and then it creates amazing views, like transits. Sometimes planets, like inner planets like Venus and Mercury, crosses the sun's disk from, as seen from Earth, you can see like dot, and these are very rare events. So this was captured last year, 2019. And then meteor showers. Right. So why astronomy? Why do you want to do astronomy, and why I do? In this image, if you look at this image, this is a very famous image captured by Voyager space telescope in the early 1970s, I believe. Here, this picture was captured 6 billion kilometers away from our Earth. And the white dot that you see in this image is our Earth, which occupies just a pixel of size in this image, just a pixel. And you can see how big our universe is and how small our Earth is. And whatever we do, we are doing it within this small speck of dust in our space. So astronomy is a study about everything. It tells who we are and what our place in the universe, and it makes us better human, because astronomy is it's a humbling and character building experience. By learning astronomy, you get to know how insignificant we are in this vast universe. And there are billions of galaxies, billions of stars and planets, and our Earth is the only planet that we ever know which has life form in it, and that's the only place we could live, at least for now. And whatever we do within this. So it kinds of, it gives you how fascinating and how unique our planet is. And when you understand that, you will always then, from then onwards, you will try to appreciate our planet Earth, and you will try to appreciate people around you, and it automatically it makes you a better human. So astronomy is fascinating, of course. And with this note, I would like to present a video just to show what our place in the universe and how big is our universe is. Right. So if you want to see more of my astrophotographs, you can follow my Instagram page, which is Prabhu Eskuti, and you can see all my everyday work. And then also you can visit our YouTube channel, Scientific Tamilans, and if you want to know more about these astronomy and paleontology and archaeology and other subjects, so we have made hundreds of videos, and you can watch all these in detail. So I hope you enjoyed. Thank you so much for the opportunity. See you once again in a different forum. Thank you.
Sir, thank you, sir. Sir, thank you, sir. Thank you so much, sir.
Sure, sure. I just want to show the meteorite. So I have
Okay,
a
sir. Okay,
small.
sir. Okay, sir. Okay, sir. Okay, sir.
So this is a small space rock. This was collected back in 2008, I believe, and this is one of the oldest rock that you can see. This was formed along with the solar system when our Earth and other planets were forming, and it's magnetic. You can see the dark surface. That's a burnt surface when it enters, and this is the inner surface. So it's magnetic. So if you bring a magnet, it attracts. That's how we can confirm that it's a meteorite. And all the shootings that you see, uh, all the bright ones, would not be bigger than this. All the bright meteors that you see in the night sky, the meteors or those small space rocks should not be bigger than a size of a small sand grain. So it's only that much in size. But if this rock enters, it can illuminate the sky, the place where you're in. So it can produce that much brightness. And this is the telescope, like I said. So light comes through this, and then through this you can see the objects. There are big telescopes, but the space is not enough to put all the telescopes here, so that's why I'm just featuring only one for now. I hope you enjoyed. Thank you.
Thank you, sir. Thank you so much, sir. Sir, can we go for question session, sir?
Yeah, please.
Thank you.
No, we cannot see the colors in dark space. what I try to understand from your question is, we cannot see the colors of nebulae unless you have a very big telescope and very good adaptation, dark adaptation. You can see some hint of the colors with big telescopes, but generally you cannot see the colors. You can only see colors if you capture image of these objects for a longer period of time, like 5-10 minutes. All the images that I've shown, these were captured for many hours. Some images were captured like for like 6-7 hours. So for the colors of planets you can observe through telescope, but not these faint objects. Already changing climate nowadays on moon. No, there are no changes on the moon because moon doesn't have atmosphere. Or if I say correctly, it has a very, very, very thin atmosphere. So there is no climate, nor anything there.
Sir, you must enjoyed the session very well, sir.
Thank you, thank you, thank you, thank you, Sushila ma'am. Was there one Big Bang or there were multiple, and will be Mars a future home? So far, whatever the evidence and the data that we have collected, it indicates only one Big Bang, but all the other theories that you may have heard of, like parallel universe, parallel Earths, multiple Big Bang, so these are just theories. So far, based on the data, it's just one Big Bang. Will be Mars our future home? It's pretty far from the future. From now, it's far in the future, because even if anything goes wrong on Earth, if we can terraform Mars and we can settle on Mars with the same resource, we could do whatever the things could go wrong. We can correct it on Earth. So it's a waste of money and time to change the Mars than our Earth. Yes, we can see Mercury and Venus, in fact, till Saturn with the naked eye. For today, if you go out, you can see Jupiter and Saturn together. It appears very bright in the eastern side. And then Mercury and Venus, you can see it even it in the evening or morning sky, depending on the time. So right now, I think Mercury is visible in the evening. Morning. So you can see it in the morning, and also you can see Venus in the morning as well.
Sir, another one I want to say something, sir. Sir,
Yes.
that Sarojini Sahu asked, you have any website?
Which one?
Any website? You are having any website?
Yes. I have my website. It's called prabhuastrophotography.com.
Okay, sir.
Sir,
you can also text, sir. You can also text in the comments, sir.
Right.
It is visible for you, sir. It'll be on the right side, sir.
Yes, I can see it. So this is my website, and then I'll also share my Instagram and then our YouTube channel as well.
Many participants are asking your website and contact number, and also many participants are willing to buy a telescope also.
Right. So I have made many videos on telescopes, like how to choose, and also I've covered all the basics of telescopes, right from working principle and types and mechanisms. So you can go through that and you will get an idea. It's very hard to answer, which telescope to get, because it's like which car to buy. It's very difficult. Only if you get to know all the things, then you will have an idea. So for now, telescopes and binoculars are far away. We have to learn the basics. And then once you know the basics, like I said, you can read things about astronomy and basics of astronomy in online, or you can watch some YouTube videos and you will have an understanding. Then you can start watching the objects with naked eye, doing observation from your terrace or from a dark sky, wherever is possible. And then you can plan on investing on a binocular. Binocular is the first thing. You have to watch bright objects like moon, planets. Planets won't appear as big as through a telescope. Binoculars give you a small and wide view, but that's the start. Once you get to know about the binocular, then it will be easy for you to handle a telescope later on. And then you can invest on a small telescope, like a beginner telescope. So it's a process. So you can find out more of these things in our YouTube channel. I'll share the link as well. Can you see the links which I'm posting? Can you all see the
No, sir. No, sir. No, sir. Sorry, you have to share your screen and.
Okay, I'm not able to post the comment in the comment section.
Sir, no problem, sir. Just you text in WhatsApp, sir. I will copy and paste here, sir.
Okay. I've sent it to your WhatsApp.
Yeah, I will copy and paste it here, sir.
I've sent it to your WhatsApp.
Okay.
Okay. So you can just search Prabhu S. Kuti in Instagram, and my website is prabhuastrophotography.com. And then our YouTube channel is Scientific Tamilans. So you can subscribe to our channel, and you can watch all our upcoming videos and the videos which we have posted earlier.
Sir, I have posted, sir. I have posted.
Yeah. So like I said, which telescope to buy and for what age, all these things I've covered in that YouTube channel. There is a playlist called Telescopes. So you can watch all the videos. There are 6 videos in the playlist. So if you're new to astronomy, like I said, first understand the basics, learn basics of astronomy, understand the objects in the sky and the motion of the sky, and then get a binocular and then a telescope. So telescope is not the first thing to do. So that's the last thing to do. Is there any problem to Earth by comets passing nearby? Sarojini Naik. There is no problem because of these comets. Only if it enters very close to our Earth's orbit, then it's a problem. Then it might change the orbital path, and it might, some of the broken pieces of that particular comet may enter our Earth, and it may impact and it may wipe out certain species on Earth. So not all the comets, only if the comet passes very close to Earth.
Okay, sir. Thank you, sir. Thank you very much, sir.
Welcome. And thank you so much once again for the opportunity, and see you all.
Thank you, sir. Thank you, sir. Thank you so much, and I have to thank our management, our college secretary, and our beloved president, and our principal, and my colleagues, and my students, and the participants. And the real success to the webinar is a real success for this webinar. All the webinar is belong to our resource person and the participant. Without you, it won't be succeed. Thank you all. Thank you, sir.
Thank you. See you all. Good evening.
Okay.